Okay, in this video, we are going to learn about the basic trigonometric ratios. So here we have a right triangle ABC. The angle here, the measure of angle C is 90 degrees. That's the reason we are calling it as a right triangle. Now we already know that the side opposite to this 90 degrees is called as the hypotenuse. And we know that it is the longest side in a right triangle. Alright, so AB is the side. This is the AB, that is the side opposite to 90 degrees, and you call it as hypotenuse. Now the other two sides, we have those two, you can call them as the legs. This is the first leg, and that is the other leg. Sometimes we call it as a short leg and long leg. Right. Now we also have the measures of the three sides of this triangle. We usually represent them by lowercase letters. Now the side opposite to this angle A is BC. BC is all the way across. That is the side opposite to angle A. We can represent it as a lowercase a. That is, the measure of BC is equal to A units. Now, the measure of this AC, the side AC is opposite to angle B. So, we can call it as B. And lastly, the hypotenuse. The hypotenuse is the opposite of angle C. That's the reason we write it as lowercase c. And this is from where we have our Pythagorean theorem: a square plus b squared is equal to c square in a given right triangle. But today in this video, actually we want to know about trigonometric ratios. Like I said before, this A, B and C are the numbers. Now in this whole triangle we have three sides, so the measures of those sides are A, B and C. It is something like 5 if I have the length of A is 5, B is something like 12, and using the theorem you will get, using this A squared plus B square equal to C square, you will end up getting C equal to 13. Likewise, these are the numbers, nothing else, A, B and C. Now, you want to know the ratio between those sides. For example, I'll write A over B. That is, from the three sides of the triangle, you are taking two sides at a time, and the ratio is A over B. And I also get other ratio as A over C, and one more ratio, B over C. So like A divide B, A over C, or B over C. These are the three ratios we have. Similarly, if I take the reciprocals, make them upside down, you can also have B over A, that is the side B over side A, and here C over A, and again C over B. So altogether there are as many as 6 ratios. There are 6 ratios in this right triangle. That is, taking two sides at a time. That is, we are finding the ratio between two sides of this right triangle, and we picked, that is, out of three sides we picked 2, and altogether we had here 6 different ratios. So mathematicians, they came up with the names for these 6 different ratios, and those names are like this. We have sine, that is the first trigonometric ratio. Then you have cosine, that is the second trigonometric ratio, and the third one is tangent. These are the three basic trigonometric ratios. So out of those 6 ratios which we have here, 3 of them are named as sine, cosine and tangent. Now their reciprocals, like we have here, for example, this A over C is a sine A. So reciprocal of that is when you flip it over, C over A. So for that, the name of that ratio is cosecant. This is the cosecant of that angle A, we can say. And the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. But for our basic study in the 10th grade, we are mainly concentrating on the first 3 ratios. We just look at these 3 ratios: sine, cosine and tangent. So in the next slide, I'll show you what is the meaning of sine, cosine and tangent. Okay, here we have a right triangle ABC, and already this angle C is 90 degrees we have. So opposite to this angle C, we have a side which we call it as hypotenuse. We already know that in any right triangle, the side opposite to 90 degrees is your hypotenuse. And now let me use this angle A as our base angle. So now for this angle A is formed by these 2 sides. The 2 sides AB and AC are meeting at this point to form an angle A. So for this angle A, already you named this side as hypotenuse. So the other side AC, which is a part of that, the point A is the end point of the side AC. So that side AC, I can call it as an adjacent side. So remember, in a right triangle, always the side opposite to 90 degrees is the hypotenuse, and this side AC, which is attached to this angle A, I can call it as an adjacent side. Okay, now the leftover side, the BC, which is all the way there, and it is ABC. You have one angle A. Opposite to this angle A, the name of the side here is BC. Okay, and that BC, it is right across and it is opposite side. Therefore, I'll call it as the opposite side for defining all our trigonometric ratios. So now with reference to this angle A, we have those 2 sides, opposite and adjacent sides. They are labeled this way. We have nothing to do with the hypotenuse. Whatever may be the triangle, whichever angle you are considering, whether it is A or B, your hypotenuse is going to be across 90 degrees angle, and it is the, it is the longest side in a right triangle. Identifying the adjacent side and the opposite side. The adjacent side is the side which is closer to this angle A, and the opposite side is right across. So this way, or you come up with your own way of remembering these names, labeling a triangle. Alright, now the first ratio, the sine of this angle A, because our reference angle today is the sine. So the sine of this angle A is, I'll write sine A here, sine A equal to it is the measure of the opposite side. Okay, it is the measure of the opposite side over hypotenuse. That is your first trigonometric ratio, sine of an angle A here. So opposite side over hypotenuse. That's the first one. Now the second ratio is cosine. So cosine A, cosine of that angle A is, it is the adjacent side over hypotenuse. So I'll get adjacent here, adjacent side over hypotenuse. And the third one, the third trig ratio is the tangent. Tangent of this angle A equal to with reference to this angle A, the tangent is opposite side over adjacent side, right? That is the tangent. Let me copy this and divide. So these are the three basic trigonometric ratios. Sine A. Sine A is opposite side over hypotenuse. Cosine A is adjacent side over hypotenuse. Tangent A is opposite side over adjacent side. For example, using the same numbers, like suppose let us say this is 5 centimeters, adjacent side is 12 centimeters, hypotenuse is 13 centimeters. So your sine A, the value of sine A, that is the ratio, is opposite side over hypotenuse. You can write 5 over 13 here. This number, that ratio gives you the value of sine A. Cosine A will be how much? The adjacent side, that is 12 over the hypotenuse 13. That's all. That is a cosine. Now if you want to find the tangent of this angle A, is the formula is what? Opposite side over adjacent side. Your opposite side is 5, so adjacent side is 12. Now also this sine, we write it as just sin, but read as sine only. Sine A, that is 5 over 13. And cosine, in short, you can just write COS, but it is cosine A, which is in this case 12 over 13. Cosine A, which is 12 divided 13. And tangent, in short, you can write TAN, tan A, that is 5 over 12. So while solving your problems, you can just write SIN for sine. For cosine, you can just write COS, and for tangent, you can represent tangent as TAN. Alright? Okay, thank you.